Okay, so today we are doing the second day of inequalities, and by the end of today, you will be able to solve inequalities using absolute value and solve real-world problems using inequalities. So with the absolute value, whenever I ask anybody what that means, the first thing they say is, oh, everything's positive. But let's think about why everything is positive. What does the absolute value measure? Yeah.
The distance.
From what? From zero, the distance from zero, right? So every single point is going to have an equivalent point on the opposite side of the number line, right? Because from 0 to 5, the distance is 5, but from 0 to negative 5, the distance is 5. So there's always going to be two separate points with the same distance from 0. Correct? Two separate points with the same distance. Okay, so as you look at that information box and you see all those absolute values and then the equivalent forms, what's something that you notice about the equivalent forms? What do they all have in them? They all have the opposite of C, right? The constant term, because you're always going to have those two different equations. You'll have the positive version and then you'll have the negative one. Okay, so as you're reading through a chart, remember, I want you to try to make sense of that. So a few things I noticed for 1 and 2, they had one long equation. Okay, they had one long equation. Are you going to have to just know what's in this chart? Yes. You're going to have to memorize it. It's going to start coming naturally to you. So it's not like you'll memorize the chart. You'll be able to interpret the situation, and then this will naturally happen. Okay, so these are both for what symbols? Less than. So notice that if it's a less than, you have one long equation. Okay, and it actually, aesthetically, it'll look nice because all of your signs will be read from left to right. Okay, the lowest number will be on the left side, the highest number will be on the right side. Now, if it is a less than, remember that's when we have the open circle. When we have the equal to, that's when we have the closed circle. Okay, so those are just little things that are nice to write down so that when you're going back through, you don't have to reread everything again. You can get the information at a glance. With the second two, notice that you have two equations for each of those. They're connected with what word? Or. So we know it has to be one of these two things. It's an either or situation. This would be an and situation. Both of them have to happen. This is going to be either or. Okay? So again, you have the opposite. I rewrote these because these are going to be more natural to you with X on the left side. All I did is I wrote X on the left instead of on the right. Remember when you're little and you first started learning about these, so they say the alligator eats the bigger number?
Yeah.
Okay, so if you look at both of them, isn't the alligator eating X? Yeah? And you guys like the shadow puppets too? What's that?
I got it.
This helped probably? Yeah. Okay. So, and then again, you're going to have that open and then that closed circle. So open for just our greater than sign and then close for the greater than equal to. Okay, so the first two are for less than, second two are for greater than. And in fact, maybe that would be something else I'd want to write down, that these are the less than, and these are the greater than. All right. All right, so for example 1, a lot of times what we tend to do is just glaze over the directions and then we go straight to the problem but we have to make sure we understand what it is asking us to do. So one thing we have to do is we have to solve. Okay, so we are gonna solve, and we're gonna solve the absolute value inequality. The next thing we're gonna do is we are going to express, and the last thing we're gonna do are going to be graph. Well, is going to be graph. Do you guys know what part of what part of speech those words are that I underlined? Solve, express, graph. Yeah, they're all verbs, right? They're all the action words. And then I just like to underline the modifiers. So solve, what are we going to solve? The absolute value inequality. Express, what are we going to express? The answer using interval notation. And then graph, what are we going to graph? The solution set. Okay, so there'll be 3 different things we're doing. Solve, express, and graph. Okay, I'm going to give you a little bit of time to see if you can use your chart to set up the equivalent form. And I very nicely wrote down your steps for you. So if you go back and you are unsure, you will know what to do first. So the first thing that you're going to do is write the equivalent form and solve. So see if you can use your chart to write the equivalent form. And then if you want to check with your elbow partner that you both have the same equivalent form before you solve, that would be great. First, let's identify what number this looks like. Okay, so Aiden, looking at my chart, does it look like 1, 2, 3, or 4?
Looks like 1.
Yeah, it looks like situation 1, right? So for situation 1, I have the opposite of C is less than X, which is less than C. Well, X is just what is inside the absolute value, and then C is your constant term. So for this, X minus 9 is inside the absolute value. What's my C in this case? 8. So the opposite of C would be negative 8. Okay, so it would be 8 and negative 8. So this is going to be your equivalent form. Right? You should have negative 8 is less than X minus 9, which is less than 8. Do you guys have questions for me on that? Whoops. Do you have questions for me on that? Now when I say this is going to come naturally, when you look at this, really what you're going to do is you're just going to tack on that greater than to the negative on the end. So it'll make one equation. Okay, so wasn't this exactly what we had there? Yeah, and then we just have the greater than negative 8.
To begin with, could you move the 9 over with the 8 so the X is by itself?
Don't do that until you have this set up, because your C is going to be 8 and negative 8. And that's what we're going to be doing next. Yeah, so I don't want you to add it over and then do 17 and negative 17. because that won't be the same. So once you add, now we're gonna add 9. Do you guys remember what to do when you have the inequality with 3 sides? You're gonna add 9 to all of them, yeah. So the left and the right and the center. So we're gonna add 9 to all of our sides. Negative 8 plus 9 is 1. 8 plus 9 is 17. And then we're gonna express that in interval notation. Okay, so when you're doing interval notation, that's gonna be with your brackets. Right, so your brackets, you wanna ask yourself, are they gonna be hard brackets? Are they gonna be soft brackets? What do you guys think? Okay, good. So soft because they are less than, there's no equal to. And what's my lowest number in this range? 1, and the highest? 17. Okay, so our interval is 1 to 17, and then we're gonna go ahead and graph that. Okay, so we have open circles, when we have soft brackets, when we have less than. Really, once you get the initial step 1 set up, from there, we've already practiced that a lot, so I feel like you guys are pretty good at graphing those. Correct? Good. Questions for me on that? All right, let's try the next one. Okay, so the next one is the absolute value of 5x plus 4 is greater than or equal to 6. So see how if you wrote the greater on your chart, you would know right away that what are your 2 options? Yeah, 3 and 4. Okay, so how many equations do we have set up for this situation? 1 or 2? 2 of them. And what word are they connected with? Or. Okay, so you should have 5x plus 4 is greater than or equal to 6, or 5x plus 4 is less than or equal to negative 6. So again, remember I said how these are going to start coming easier to you? Look at your original problem and then the first one I wrote down. What's the only change I made from the original to the new one? Yeah, you just took away the absolute value. And then for the second one, you have the negative 6, but what else changed besides the negative? The sign. So the way I remember that is, remember the rule, if you multiply by a negative, you have to flip the sign. I think to myself, oh, it's like I multiply by a negative, and I have to remember to flip the sign. Okay, so that's how I remember that you are going to flip it. Okay, so it's going to be negative, and then you're going to flip the sign. So now you're going to solve each one for x. I know many of you already have. Okay, so if you subtract 4, then divide by 5, you'll get 2/5. Okay, you should leave it like that when you're using our calculator. And negative 6 minus 4 is negative 10. When you divide that by 5, you get negative 2. So either x is greater than or equal to 2/5, or x is less than or equal to negative 2. So now we have to write that in interval notation. So that's a little bit trickier than the last one. So I want you to think about what would be your lowest point and your highest point. So this one is x is greater than or equal to 2/5. So is this going to infinity or negative infinity? If x is greater than or equal to 2/5. Positive infinity, right? And 2/5, okay? X is less than or equal to -2. That's going where? Okay, so I'm probably going to start with this interval here. Okay, so it would be negative infinity up until what? -2. And what kind of bracket do I have to have on -2? Soft or hard? Hard bracket, good. And then how am I going to link these two together? The union, you got it. Okay, so we're going to start with the lower interval, so negative infinity to -2. And then we're going to link that with our union, which is 2/5 to 8. Or sorry, 2/5 to infinity, sorry. To a sideways 8. Okay, and then we're going to go ahead and graph. Remember, I want you to continue to put those above the line so I can see your circles clearly and then your numbers clearly as well. And then you can see now why you have to connect them with an or. Are you going to have any number that can be greater than 2/5 and less than -2 at the same time? No. If you look at the one above, are there numbers that can be greater than 1 and less than 17 at the same time? Yes. So let's talk about checking our work to make sure that it does make sense in terms of the problem. So for part A, my solutions are in between 1 and 17. And if I pick any number between 1 and 17, this should be a true statement. All right, so Dylan, give me a number between 1 and 17.
5.
Okay, so let's plug in 5. So 5 minus 9 is? -4. What's the absolute value of -4? 4. Is 4 less than 8? Yep. Okay, let's pick one outside it. What's a good one to pick that's outside it? 0. Okay, so 0 minus 9 is -9. Absolute value would be 9. Is 9 less than 8? No. So that's good, remember, because it's false. Okay, and that's what we wanted it to be. All right. What about for this interval? So if I want to check to see if it's true, first let's pick one in this. Negative infinity to -2. Okay, so we'll do -5. So this would be -25 plus 4, which is -21. Absolute value is 21. Would that be greater than or equal to 6? Yeah. Okay, let's pick one greater than 2/5. 1. So 5 plus 4 is 9. Absolute value of 9, is that greater than or equal to 6? Yep. Let's pick one that's going to be false.
0.
Okay, so then if we do 0, we'd have 4. Is 4 greater than or equal to 6?
No.
No. So do you guys see how you can plug that back in to check to make sure it does make sense in terms of your problem here? All right. Okay, so on the back, we are going to start modeling, not Kendall Jenner style, the math modeling kind. So what I want you to do is read through that. And then next to plan A and plan B, I want you to see if you can write an expression for each of those. And if you want to set up the inequality and solve, go ahead. the types of expressions you have are linear expressions, right? It's going up by the same amount each time, and then you're charged a flat fee to get it. So Henrik, for Plan A, what was your expression?
I said 0.5x plus 7.
Okay, so let's go over what that represents. Like, what does your 0.5 represent?
0.5 represents the cost per ride.
Okay, good. And X represents?
Number of rides
Yep. And then the $7?
is the fee.
Good. Okay, your entrance fee. So 50 cents per ride, so 0.50 times the amount of rides you do, right? And then plus 7. Your second one will be very similar. It will be 0.75x plus 3. Okay, how do we do with those? I came around, it looked like you guys were doing pretty well. Now, let's figure out what we have to find for this. How many rides would you have to take for Plan A to be less expensive than Plan B? So I chose to highlight that. You should underline it if you don't have a highlighter, so that you understand, hey, what am I trying to find here? Okay, so Plan A to be less expensive than Plan B. When you're setting up your equation, all I did is I started with Plan A and then Plan B. So Plan A, Plan B, and then I have to decide what kind of symbol to put in between them. What were you guys thinking?
Less than.
Less than. Plan A has to be less than. Can it be less than equal to?
No. Just then they'd be the same price.
Okay, good. So if they were less than or equal to, they'd be the same price. And if it was the same, then would it really matter which plan you chose? No. Okay. All right, so if Plan A is less than Plan B, let's just go ahead and set up what we plugged in for Plan A. So Plan A is 50 cents per ride, and then a $7 entrance fee, and then 75 cents per ride, and a $3 entrance fee. And then we're gonna solve that for X. So the first thing I'm gonna do is I'm gonna move all of my X's to one side, and I like to keep my X's on the left side. So that's what I'm gonna do. So this would be negative, what's the difference between 50 cents and 75 cents? 25 cents. And then I'm also gonna subtract 7 at the same time, if that's okay. Alright, now, negative 0.25 is the same as what number? 1/4, right? If we're not using our calculator, then this is going to be easier. So now if I want to move that over, Kaden, what would I do to both sides?
Multiply both sides by 4.
Close. I've multiplied both sides by, if you multiply by 4,
Oh,
then you
negative.
get, yeah, negative 4. Good. Okay, now when you multiply both sides by a negative, something special happens. Do you guys remember? Yeah, the sign is going to flip, so do not write this. It has to be X's greater than 16. Okay, and I actually wrote a little note there. So when you multiply or divide by a negative, okay, then you have to flip the sign. Okay, and this was another way to solve it. I divided by -1 here first, then I multiplied by 4. You can actually just multiply by -4 first. That would be the same exact thing. And that's what we did together. That's what we did together there. Okay, so now let's interpret that in terms of the problem. So if X is greater than 16, what does that mean?
More than 16 rides.
Okay, yeah, so if you ride more than 16 rides, then what though? Then Plan A is less expensive or Plan B is more expensive. Okay, so I said if you plan to ride / go on more than 16 rides, then Plan A is less expensive. Is there another way that you guys could say that? What's another way to say more than 16 for this?
17 or more.
Yeah, 17 or more, right? So if you plan to ride 17 or more rides, plan A is gonna be less expensive, right? Because you can't ride partially. Unless it gets stuck, and then I'll pray for you. All right, questions for me on that one? Okay, I'm gonna give you some time to read example 3. And as you're reading, I would highlight or underline important parts there. Okay, so GC, what's one important piece of information that we learned from this?
That it goes 40 degrees during the afternoon, but cools down 5 degrees at night.
Okay, good. So it's 40 degrees Celsius during the afternoon, but it calms down to 5 degrees Celsius at night. Then I also highlighted, what do I have to do here? Okay, so Josh, what are we trying to do for this problem?
Find the range of the temperature.
Yeah, we're trying to find the range of the temperatures and how they correspond on the Fahrenheit scale. And then in order to solve this, we had to know the conversion equation. So the relationship between them. Celsius is equal to 5/9 multiplied by the Fahrenheit temperature minus 32. Okay, so you subtract 32 from your Fahrenheit temperature first and then multiply by 5/9. So what we're going to try to do is we're going to try to set up an inequality. Do you guys think that you could set up an inequality in terms of just Celsius? Well, what's the lowest Celsius value it goes to? 5. And then what's the highest one it goes to? 40. Okay, so isn't our range of values just 5 degrees Celsius to 40 degrees Celsius? Right? It goes down to 5, but it goes up to 40. When you see those, don't they just sound so cheap? Okay, but we want to figure out what they are on the Fahrenheit scale. How could I do that, setting it up with an equation? What do we know C equals?
5/9.
Yeah, 5/9 F minus 32, right? Okay, so we know that in order to convert, I just have to use my relationship equation. So in terms of Fahrenheit, it would be 5/9 and then F minus 32, and then your range is going to stay the same. So really, I just have to solve that inequality for what? I just have to solve it for F. So there's really 2 different ways you can start this. What are you guys' thoughts? What are you thinking you do first? Okay, so one thing you could do is distribute the 5/9. You could also multiply by the reciprocal, right? Which one do you guys think is going to be easier for you?
Reciprocal.
I think multiplying by the reciprocal will be easier for you too. You're still gonna have to multiply by a fraction. But remember, when you're multiplying by a fraction, multiply the top by the top, and then you divide by the bottom. Okay, so 5 times 9/5. What happens there? The 5s are going to cancel out, right? Because 5 divided by 5 is 1. Is that okay? You could also think of it as 5 times 9 divided by 5. 45 divided by 5 is 9. Okay? In the center, we're just going to have f minus 32. The parentheses are now gone away. Now we're going to do 40 times 9 over 5. Again, when you're doing this without a calculator, do you really want to do 360 divided by 5? No. Let's simplify it. How many times does 5 go into 40? 8. And 5 goes into itself once. Okay? So 8 times 9 is 72. Okay, and then Eddie, what's going to be my last step? Yeah, you're just going to add 32 to each side. Okay, so again, to do this in your head, do you guys add 10 and then subtract 1? Do you think about that?
No, I just know what the 10 value is.
Yeah, and then you just go one less. Yeah, exactly. Yep, 42 minus 1, 41. Okay, for this, it's easy to add straight down. 2 and 2 is 4. This would be 10. Okay, so 5 degrees Celsius is equivalent to what in Fahrenheit? 41 degrees. And then, good goodness, 40 degrees Celsius is what? 104. It's getting hot in here. Nelly. You guys know that song? It's from the 2000s. So 104, we are not going to see those temperatures soon, I hope. Okay, so then that's going to be your Fahrenheit. 104 degrees. And then that's what you had to do, is you had to do your range. That is your range. And so your solution is 41 degrees. So I'm going to say that range from 41 degrees Fahrenheit to 104 degrees Fahrenheit. Okay, and then there is your homework for 1.7. Again, I would make sure that I'm updating my log so that you have all of that ready to go for Thursday.